So, uh, good evening and welcome to this edition of Tech Talk. It gives us great pleasure to introduce the team at Hexeves who've joined Alex and I today. CEO and co-founder Dipalo Abbat brings the team significant experience as he's an entrepreneur with experience in international business, project management and execution, design thinking, marketing and sales. He's founded 2 businesses before Hexaves. Having a degree in chemical engineering and an MSc in international business and management means that Delapo can easily and quickly transition between the technical and commercial, a critical skill for deep tech startup founder. And I can relate to that. I think it's always very difficult to integrate between the science people and the business people. So Delapo has a passion for developing innovative technologies at the intersection of art, design, engineering, and science to address the world's pressing environmental challenges. And this is exactly what he plans to do at Hexeves. He's driven to be strong, committed to contributing a more sustainable future. Also joining Delapo is CTO and co-founder Lokshwar Bandhu, or Lockie. So Lockie is the CTO of Hexeves. He's an expert in material science and nanotechnology. I can relate to that tremendously. He spent more than 13 years developing nanomaterial-based devices, formulating and synthesizing nanomaterials. Notably, he's built first-of-its-kind solid-state reflective displays composed of ultra-thin films at a nanometer scale. For his PhD, Lockie built a first-of-its-kind phase-shift graphene-based sensor. His more recent project was developing a novel plasma deposition tool used to manufacture current collectors used in the production of lighter and safer batteries. His material expertise also extends to the synthesis of carbon nanotubes and other 2D nanomaterials. Lockie is a well-respected author and inventor. He's published several highly cited research papers and patents. So now if I hand over to Alex to briefly introduce himself, and then Alex will hand back to me. Floor is yours, Alex.
Yeah, no, great to see you, John, and nice to meet you, Delapo and Lockie. I'm Alex, co-founder and CEO of Natrion. We're a battery technology startup based in the US. We've been around since about 2018, and we focus on what are called solid-state batteries, where we're trying to improve the performance and the safety of batteries, especially for automotive and electric vehicle applications, but also other use cases like drones, consumer electronics, and so forth. We are kind of entering a scale-up phase, so but still pretty small, so 20 staff on our team, and building our first production line, which we hope to have online in the next 2 years or so. So very nice to meet you, and looking forward to today's conversation.
Oh, great. Thanks for a really good introduction from yourself. I'm just very briefly, I'm John Tuck. I'm a holistic energy scientist representing Silent Koala. I've got about, over 20 years of experience in the energy storage and energy generation industry across the range of technologies from commercially available product to blue sky innovation. I work predominantly in intellectual property for a battery manufacturing company in the UK, and I'm a consultant and advisor to startup technology companies. Now, Delapo reached out to me recently, having been referred to me by APC, which is the Advanced Propulsion Centre, and Faraday Institute of Innovate UK. And it was a great pleasure to have the initial chat and to find out more about what these guys are up to at Hexeves. It looks like really exciting stuff. So it gives me great pleasure to hand the floor over to Delapo and Lokshwar to introduce themselves and to begin our discussions. So Lokshwar, if you want to introduce yourself, we'd love to find out more about you.
Thank you for the kind introduction earlier. Yeah, so we are. I'm sorry about the noise.
No worries.
Okay. Yeah. So yeah, we've kind of touched upon my past experience. I'll tell you briefly about what we are doing at Exavis. So we met at a venture builder platform called Carbon 13. And I and Dolapo and our another co-founder, Taf Mossi, had we all share a passion for nanomaterials and solving this problem in the energy storage solution space, specifically related to batteries. And we came down to the point that we all realized we need high density batteries and high power density batteries to solve this, to electrify this hard to decarbonize sectors, such as shipping or aviation or power performance vehicles or off-grid vehicles like mining industry, agriculture, heavy goods vehicles, and so on. And one thing led to another, and we kind of narrowed it down to the point we realized the space we want to solve is lithium metal batteries, using lithium metal anodes for high energy density applications. And we realized the problems in there. And based on our experience of nanomaterials and material science, we are developing a special coating of nanomaterials for lithium metal anodes, which is specifically designed for solving the challenges of dendrites and unstable soil electrolyte interface layers in lithium metals. So that's what we are at. We are a very early stage company. We are only developing our proof of concept devices at the moment, but we are getting some really promising results. And if everything goes well, we hope to scale up, or we hope to have our first round of fundings and continue to scale up in the coming year.
Great, thank you, Lockie. That was brilliant. Thank you, Dolapo.
Yeah, thank you, John. Thank you, Alex, for the talk. It was really nice speaking to you in our previous chats. And just as Lockie mentioned, we're trying to solve problems with next generation battery components. My approach was from a more top-down approach, in terms of when you look around and you see that a lot of sectors are still not electrified. And my question was, why is it that only 1% of heavy goods vehicles have been electrified? What are we going to do about ships? What are we going to do about airplanes? If we're serious about the climate crisis, we need to start doing something about this. So that's how I came to meet Dr. Bandhu and Dr. Moti, who are the co-founders. So I personally am very mission driven, and a lot of what guides my decision isn't really the details. It's more of the grand vision of trying to make an impact.
Yeah, thank you, Dolapo, and I can relate to that. I often find myself best positioned in the bigger picture. So not necessarily focusing on the detail. I mean, the detail is important, of course, but I like to look at the bigger picture and see, what's going on and slot everything into the bigger picture. So yeah, thank you for that. Yeah, I mean, I think we've all got tremendous tangents in our careers and ambitions. For me personally, it's exciting to talk to you because I have a lot of experience in nanomaterials. I'm originally or officially a materials scientist. I've spent a long time working with carbon like nanomaterials and all sorts of synthesis and characterization. And for me, I'd be curious immediately just how you characterize or measure your nanofilms and what type of equipment you use to do that.
Yeah, so as I said, we are still at a very early stage. So we use the traditional methods of characterization. For example, our cell performance is was just measuring the electrochemical potential and number of cycles, charging, discharging capacity curves. But for our protective coating layer, We use EDX, SEM, and XPS analysis mostly. But yeah, I mean, a lot of that characterization is also will be developed as we study more and more about it. We are partnering with there is a there is a research organization here called Warwick Manufacturing Group, who have
Yeah.
all the facilities for the forensics of a battery. So as we go deeper and deeper into it, we will use those forensics for studying where exactly our battery is failing and where exactly our protective layer needs more strengthening.
No, fantastic. Thank you, Lucky. And I guess moving forward, you also have an interest in solid state. Do you have any questions for Alex?
Yes, it'll be great. So eventually, we do want to move to solid state batteries because we think that's the future for it. But as we are approaching this solution, to us, it makes commercial and strategic sense to enter it through a liquid electrolyte phase. But yeah, eventually we do want to go to solid electrolyte, solid state electrolyte. I guess I have plenty of questions, but maybe if we can just get some intro on where Natran is currently, that'll probably help us better in forming those questions.
Yeah. Yeah, and I'm very curious to learn more about your solution. So at the where we're at is we are prototyping lithium metal pouch cells right now in-house using our solid state electrolyte, and are running into very much the same challenges as everybody else, the dendrites and the runaway SCI growth you've mentioned. Definitely lithium metal, definitely the main advantage is the energy density, right? And even some improvements in charging performance as compared to state-of-the-art lithium ion. But cycle life is charge discharge cycles is the big question. And I think for solid state in particular, most of the material is developed. You'd think putting a highly electrically conductive metal like lithium metal against a solid electrolyte material, the interface should, even though it's a solid state interface, it shouldn't be that difficult, right? But it to make that work, but still you have very high resistivity depending on the quality of your lithium metal. If, for example, most lithium metal right now is made with extrusion, right? And so the surface quality can have these extrusion processes, they kind of stretch out the lithium metal between rollers under silicon oil, and so you can have silicon contaminants of the lithium surface, oxide carbonate contaminants, not to mention the actual grains and the grain boundaries of the lithium metal itself is going to pose problems. And that then translates to heavily to, you're going to have issues with dendrite nucleation and instability of the interface with the solid electrolyte and high resistance at the interface with the solid electrolyte. So these are all things, things that we're up against as well as everybody else in the industry. And so, one thing that we're trying to work on in particular is lithium metal cells with low stack pressure requirements. So one way that people are getting around these issues at the interface between a solid electrolyte and lithium metal anode is just putting the whole cell stack under a whole bunch of uniaxial compression. The problem with that is you need to put cells in some kind of clamping device then. So now when you go and build an electric vehicle battery pack, you have to worry about not just the weight of the cell, but also the required clamping. And so even if you get great energy density at the cell level, that's probably not going to translate to great battery pack energy density. So it's anytime you're dealing with lithium metal and solid state, it's a world of hurt. And something that we and a number of others in the industry have to navigate. So, yeah.
I mean, I was coming to that because, it's so I guess you are targeting just the high energy density batteries, and you are happy to compromise on the power density aspect of it. Is that right?
Yeah, to some extent, I think, yeah, initially we want to, initially we want to optimize energy density because automotive, for most automotive manufacturers, they're still pretty okay with 1 hour to 3 hour charging, right? Yeah, there's some automakers that are quite adamant about, ultra fast charging, like, 15-minute or so forth. But most automakers find, if you're cycling battery cells at 0 or 3, that's adequate for them and generating cycle life data. Now, we also know that in general with lithium metal, right, the rule of thumb is slower charge, faster discharge. And you'll see a lot of other companies producing data where they're using like 0 or 5 or 5 hour charging, but then 1 hour discharge. And they get great cycle life, but that's not really practical. In an electric vehicle use case, you probably actually want faster charge and a slower discharge rate.
Yeah.
Or at least that's going to mimic real use case more. We internally, we try to use symmetric cycling protocols as much as possible and use, for the most part, we cycle cells between 1C and 3 rate, and then an equivalent discharge rate. But yeah, getting lithium metal to cycle is hard enough. I think power density is going to be a separate bridge to cross over. Really, and with solid state especially, right? It's solid electrolytes. You have the added challenge of, well, how do you get the solid electrolyte itself to facilitate sufficient current density and ion flux? So a lot of hurdles to jump through for certain.
Right. Yeah, another question perhaps, which is, partly we are facing as well, is the characterization of our coating on lithium metal anodes, because it has to be in situ, right? Because of the high reactivity of lithium, its characterization becomes a real big challenge. Did you come across such challenges, and how did you overcome that?
Yeah. It's definitely something that's been a major stumbling block for us as well. And you do have to get creative, right? So it's interesting though, because the whole industry is kind of getting together around this. Like I saw a LinkedIn post the other day. This guy's like, hey, I can machine this for anybody who wants this, but it's basically a little container that you can seal lithium metal cells inside of it in a glove box antechamber, and then it'll keep the sample under inert argon and atmosphere, and then the container will only open up once it's under the high vacuum inside of an SEM. So it's a way to get samples out of a glove box into an SEM without without exposing the sample to air.
It sounds a bit like Schrodinger's cat almost.
Basically, kind of, yeah. No, it's definitely a nifty contraption. Although the guy does charge $1,000 for it, but I think it's worth it.
Sounds it.
But yeah, so the industry is there's a lot of great work in academia as well. So recently we visited the Paul Scherrer Institute in Switzerland. Something they do, they're really great at is, well, they have a synchrotron, so yeah, they have all sorts of crazy characterization that they do. But they've also, they like cells where you have cells where you have a cavity, so you could do like in situ NMR as the cell is cycling, or neutron imaging and stuff like that. So at the moment, we, at least Natreon in-house, we're doing virtually all the same stuff as you, though: EDX, XPS, SEM, and just getting creative about how to get the samples into these instruments without them degrading or getting exposed.
Yes, so thank you for that, Alex. Yeah, it's a critical problem, and as you said, we have to be creative about it. Yeah, and actually, I mean, I because you are further down the line compared to us, I'm just curious as to what are the problems, or what are your suggestions to overcome challenges of going from a coin cell to pouch cell? because it's great to show it, at a proof of concept as a coin cell level, but as you move to pouch cell, it's a slightly different size, slightly different chemistry going on, and all those unwanted reactions coming because of the size. How do you, I mean, obviously it has to be optimized, but what are the challenges that you face?
Yeah. No, that, I mean, that's all we've been doing for the past 2 years is making the transition from coin to pouch. So we raised a seed round specifically, this is what we told investors is, look, if anybody in the automotive sector is going to care about us and what we're making, they need to see pouch cell level data, and that's what we need to produce. And we need some way of prototyping pouch cells in-house. So that's what we need your money for. And yeah, I think granted, we made a lot of mistakes, right? But I think if, as far as looking back at things that we did well, what was helpful for us was just from the outset knowing what kind of you almost want to produce like a specification, right, of your goal pouch cell. Like what is the, so as far as a pouch cell that is going to be relevant to the industry and get you across your different business goals, what does that pouch cell look like? What kind of performance does it generate? What are the dimensions? What kind of cathode and anode does it use, electrolyte, and so forth? So we knew that we wanted to have a 2-layer pouch cell because that's the bare minimum to say it's a multi-layer pouch. And that it would be a high nickel NMC, so for the high energy. On the anode side, we wanted to use the thinnest lithium possible. So we said, look, we're only going to use lithium metal anode that's between 6.5 and 20 micrometers in thickness. And that it would have a low stack pressure requirement for cycling. So we would limit ourselves to a maximum of 3.4 and more recently 2.3 atmospheres of external stack pressure. I think the other thing that was helpful for us was, again, keeping it as industry relevant from the beginning as possible. So I know of a lot of folks who start pouch cell prototyping, but they're still using really low loading cathodes, like 1 milliamp hour per centimeter squared aerial capacity. Now, that's fine for an academic study, but you go to industry, they ask you about your cathode loading. I mean, that's maybe 1/4 of what is used in lithium ion right now. And so if you have C/3 cycling, people know that the current density is 1/4 of what's C/3 for an actual lithium ion battery cell. So from the get-go, we jumped to high loading cathodes, to industry relevant cycling rates. And the pouch cell performance is going to suck in the beginning. You're going to get 10, 20 cycles, but it's like, how do you, at least if you start there, right, you're working with a pouch cell that's going to be very close to what your end product wants to be, you want your end product to be. And you're not first going to optimize performance for a low loading cathode pouch, and then people are going to ask you to make a jump to a higher loading cathode, and then you have to re-optimize again. So just jump into the deep end with pouch cell development would be my suggestion, from the get-go.
That sounds like great advice. And I can assure you, Alex, your mistakes were of extreme value to you. If you're not making mistakes, you're not moving forward.
Absolutely.
So John always said, yep, you're not learning. Yeah.
And I would like to ask, so from a commercial point of view, you said there are certain things you told to investors. How did you find the fundraising journey in America? Because I'm sure it would be different than what we're going through in the UK. Did you have IP before fundraising, or did you develop the IP after fundraising? And how was the conversation with investors? What were the things that you would say are super important if you were going back to the beginning?
Yeah, no, we had a couple of patent filings, but I think this is where John, as a mentor to our team, was especially instrumental. Is his IP background. So John helped us put together an IP strategy that was quite robust, and it's one thing to not have IP, but at least have a plan for how you're going to generate it, and how it's going to be valuable, and differentiate you within the market. So as long as you And seed stage investors know that, like, they know you might not have much, but they at least want you to see that you've put a lot of thought to what you want to do and execute.
Okay.
It's it might sound strange, but it's really the thoughtfulness that counts with seed investors. They want you to have a plan um, and beyond just having a budget for how you're going to spend their money. The other thing is, yeah, although in the outset we got a lot of our first dollars from American investors, funny enough, I think a bulk of our seed round actually came from European investors. And so European investors in particular at seed stage are very knowledgeable of the clean tech space or the battery space. And what we found was very critical to converting conversations and getting genuine interest is, again, the differentiation, right? So there's battery there have been battery startups or battery technology has been a big field of innovation, especially for startups for about 15 years now, right? There's so in some sense like there are probably hundreds of battery startups out there, right? And investors know this, and they want you to also be able to very clearly know and articulate how you set yourself apart, and being able to distinguish yourself, and name other startups and what the distinction is between you and them goes a long way, because investors there definitely has been some saturation in this space in the past couple of years, and investors know that it's been booms and busts, right? And so that's the other piece of advice I'd offer.
Very wise words, Alex.
Interesting. And you guys are about 20 now, you said.
20 on our team, yeah.
So are you still at what stage would you classify your company as now? Is it seed or Series A?
So we're raising our Series A right now, specifically for the production scale up I mentioned. Yeah.
Oh, okay, nice. And how many years was the journey?
Sorry, what was the question?
It's been about
So
five or 6 years now.
From seed to Series A.
Oh,
Yeah. I think we fully, so like I said, the seed our seed round kind of had a seed and a seed extension, really. So we had kind of two closes to the seed. I'd say the seed extension closed last year, and the seed round, the first part of the seed round the year before that. Yeah.
Nice. Interesting. So we're still pre-seed at the moment. So we're still quite early, and it'll be good even after the call to just continue the conversation in terms of the space that we're trying to solve. So have you thought about the practical applications or who your practical customers could be? So not just like for us, for example, we see maybe heavy goods vehicles might be the first adopters of our technology. Do you have a similar view, or are you just making sure the technology is available?
Yeah. We've kind of taken a two-pronged approach. One is like, the biggest market in which we can offer the most value is definitely automotive, and EVs. And early engaging with the automakers early on is, right now we don't have the pouch cells that we prototype. They're something like 48 by 56 millimeters. I mean, they're like smartphone size, right?
Yeah.
We don't have a 100 amp hour pouch cell to send to an automaker, right? But still, we've engaged with our R&D teams early and been able to land evaluations with automakers operating in that smaller miniaturized pouch cell scale, because that early automaker buy-in is important. So our Series A round we're raising right now, there's a potential that a lot of the funding within that round will come from some of the automakers and so large cell manufacturers we've engaged with. Now, that said, to be generating revenue from the automotive market, it's going to take a while for us to be at a scale where we'd be able to accomplish something like that. You know, you physically need enough material for multi-megawatt hours, if not gigawatt hours of cell production. So how can we, so we thought about how can we generate revenue in the near term in perhaps lower volume, higher margin use cases. And something that's been really interesting for us is, you know, for instance, defense applications. So we've worked with the U.S. Department of Defense on batteries for tactical radios. I mean, radios are every infantry has radios. These radios for communications, and these are small, relatively small battery packs inside the radios, about 4 amp hours. So we can easily jerry rig together a prototype battery pack with a couple of our smartphone size cells for that, right? And get, field testing and validation, and and it's not even it'd be the federal government buying from us, which is it takes a while, but once you get that set up, those could be massive contracts, and investors know this, and that also goes a long way with investors, right? Is having 2 channels of potential sales, this long-term one in automotive and more near-term ones in defense and consumer electronics and so forth. So
that's non-rechargeable batteries.
No, they're rechargeable.
Rechargeable. Okay, nice.
I think sorry to interrupt, Dolapo, but I
No,
think
it's fine. Yeah.
I think just to interject at this point, I think what Alex is saying about having 2 channels is important, because generally speaking, when you go to investor, if you have 1, it's not enough, but if you have 5, it's too many. So 2 or 3 is the ideal number to let investors know you're serious and you're doing and you're focused, because focus is absolute key. Sorry to interrupt.
No, it's okay. I guess the next thing I was gonna ask was, I know America is big on the Inflation Reduction Act. So have you guys been able to benefit from that, or any other government? Because I can see you just mentioned you're working with the Defense Department of Defense. Would you advise like ourselves to consider that? Are you benefiting from the IRA or any of some of the laws that have been put in place recently?
So the IRA is interesting. It's definitely changed the environment in the US and made things pretty competitive with the EU. So I think most of the benefits of IRA are kind of if you're in manufacturing scale up. That's really what I think the federal government here is trying to accomplish, is domestic manufacturing capabilities, and especially decoupling, as it pertains to decoupling from China, and other challenging supply chain elements. And for us, no, nothing in particular about the IRA that's really kicked in for us, just because I think we are a bit too early. So once we're building out our production line, and if we continue to scale after that, there will be benefits we'll be able to take advantage of. And although to some extent, what we have done, for example, is so the IRA in particular, what it does is it really supports manufacturing for even foreign companies with which the U.S. has free trade agreements with. And so for us, for example, we've started working with a lot of companies from Japan and South Korea who are trying to set up manufacturing in the U.S. because we have free trade agreements with those. And and in investor conversations, so this is a name we're allowed to talk about publicly, LG Energy Solutions. So they're a company we've been working with. And of course, battery manufacturing giant, and a company that stands to benefit greatly from IRA. And so they're going to be building up, they've already announced 400 gigawatt hours of new cell production capacity they want to build in North America. And so when we go to investors, we say, hey, look, we're working with this company. Just picture this. Yeah, we service about 5% of their cell production. How much revenue is that for us, right? And so then that becomes very tangible for investors to think about. And it's all hypothetical, right? But that's an example of because ultimately we'll at least with the bigger automotive manufacturers involved with the automotive industry, we're probably just going to license our materials and our methods. And the big concern there for investors is always, how do you capture enough value? Because if you're just licensing, you're making a couple of cents on whatever unit. So it's a volume game, and so being able to work together with big foreign manufacturers who are gaining a foothold in the U.S. Has been helpful.
Awesome. I don't know.
I have a quick question about on the technical side. So Alex, I wanted to have your insight on how do you see the other technologies that are running in parallel with lithium anodes, like silicon anodes and niobium based electrodes and all. So I guess the question is, what do you see as the biggest competition, and where does your technology stand in comparison to them?
Yeah. How we think about ourselves being positioned within the market is the real advantage of our solid state technology in particular is our compatibility with lithium ion roll-to-roll production processes. So everybody, to our understanding, most others who have attempted to commercialize a solid state technology have tried to go to market with a solution where the cell manufacturing process and the cell design has to be fundamentally reworked. And I think it was in like Porsche Consulting magazine recently, they looked at like sulfide solid electrolyte materials and oxide based solid electrolyte materials, and they found that in general, working with those materials, you're looking at replacing or modifying significantly 60% of lithium ion production process. And where we've tried to really find our niche is, we thought about all this, and like guys like Panasonic or LG or some of the other big manufacturers in this industry who are operating gigafactories, they're not going to reconfigure 60% of their gigafactory floors. They've spent 30 years perfecting their production processes, and so they need a better solution if they're going to adapt something. And that's where we think we have our kind of island of uniqueness, is that our solid electrolyte solution can work with these existing gigafactories. More broadly, we like lithium metal just because I think silicon is a great stepping stone between graphite and lithium metal. But lithium metal is really kind of the ultimate holy grail, and really what will finally bring together this combination of performance and safety and longevity that you need for mass market electric vehicles that mainstream consumers will want from EVs, and similarly then electric aviation. So silicon is to us, like silicon is interesting from like the point of view that you can make blends with graphite right now and boost the performance of lithium ion pretty easily. But some of these like pure silicon plays, like you're talking about materials, silicon anode materials being made with essentially semiconductor processes, some of these vapor deposition processes that are batch based, that are going to be low throughput, pretty high cost. And so the cost benefit there, it's tough for us to see clearly. And that's outside all of the challenges that you still have with those materials around cycle life, around volumetric expansion. So that's, I don't know, silicon can be a whole conversation unto itself.
Thank you so much.
No, thanks, Alex. And we're in danger of overrunning now, which is testament to the great conversations we've had. I think we got time for a couple more questions if you've got any more for anyone.
I don't know, Alex, do you have any for us?
Yeah, just we'd love to hear a bit more about this coating for lithium metal and yeah, and whether there's is this agnostic to like whether it's rolled lithium metal or vapor deposit lithium metal, and also like processing, like are you is this something you have to do in a glove box? Can this be done in like a dry room environment? I'm just curious.
Yeah, it's a good question. So, I mean, our technology in itself is a platform technology, so it'll be agnostic to, whatever kind of lithium you have. And yes, there are challenges on, how we are going to implement, but the solution we are looking at and exploring currently is fully scalable and will be a roll-to-roll deposition based one. But yeah, I mean, the challenges we are facing is to have a uniform coating of our nanomaterial over lithium. And I think once we sort that out, we are pretty good for trying for different kind of liquid electrolytes, solid state electrolytes, or lithium ion, so sodium ion, whatever kind of battery chemistry. I think our protective coating is going to be agnostic to that.
Yeah, and I think also from initial discussions with you guys, it seems like many of the challenges that Alex originally iterated are exactly what you're working with. So reduction of dendrite and better contact or less resistance between the interface between the electrode and the electrolyte. So particularly in solid state situations. So it sounds as if you guys are working towards absolutely the right path. And it's been a great discussion today. Thank you so much.
Thank you.
Thank you so much for having us here.
Thank you so much for
Yeah.
having us.
Thank you.
Yeah, great. So yeah, just to finish off, thanks to anyone watching this. It's been probably one of the most detailed technical discussions we've had, which is really great. Really enjoyed it, and I hope everybody else enjoys this too. And Alex and I will see you next time for the next edition. Thank you very much. Thanks to
Thank
everyone.
you.
Thanks, Alex.
Thank
you.
Bye.
Bye.
Lucky.
Take care.
Thank
Bye,
you.
everybody.
Speak soon.
Have a good
Bye.
day.